In this chapter, we will be studying trigonometry. In this lesson, we're going to be looking at the ambiguous case of the sine law.
Okay, hi everybody. So now that you've seen the sine law, we're going to look at a part 2 of this. We're going to look at the ambiguous case of the sine law. Okay, now remember, the word ambiguous means not clear. So let me show you what's going on here, what's happening. So this question tells us to find the measure of angle ACB. So ACB, we're looking for this angle right there. Okay, so I look at what I'm given, and I notice that I've got an angle and a side, and they're opposite each other in the triangle. So I know that this is going to be a sine law problem. Okay, that's the minimum information I need to use the sine law. So I'm going to set that up. So I'm going to have 4, okay, over the sine of 30 degrees. And that's going to be equal to 6 over the sine of C. Okay, now once I've got this proportion set up in the sine law, I'm going to cross multiply. So I'm going to get 4 multiplied by the sine of C is equal to 6 multiplied by the sine of 30 degrees. Okay, and then I'm going to solve for the sine of C. So the sine of C here is going to equal 6 sine of 30 degrees divided by 4. I'm going to enter this into my calculator. Okay, so 6 sine of 30 degrees divided by 4. And I get 0.75. Okay, so the sine of C is equal to 0.75. Now, once you're at this point right here, you know that you're going to take the inverse sine of 0.75. But I want you to think about that. Kind of at this point here, divorce the question, this part of the question, from the context. If I was to just ask you what is the sine, for what value of C is the sine of C 0.75, what you'd have to think here is, well, okay, what 2 quadrants is sine positive in? And that's going to be quadrant 1 and quadrant 2. So it could be this angle or this angle. So it turns out there are actually 2 different solutions to this. Okay, now most of the time when you go to your calculator, people are going to tell me, well, C is equal to the inverse sine of 0.75. And so if I do that on my calculator, okay, the inverse sine of 0.75, well, I'm going to get 48.5 degrees, so 49 degrees. So C is equal to 49 degrees. Well, look at that. That angle here in this triangle, assuming that this triangle is roughly drawn to scale, that is nowhere near 50 degrees. That's much lower. This is an obtuse angle. But the reason it looks like that is because there is a second quadrant angle that can satisfy this expression right here. So how do I get that second quadrant angle? Well, remember what I do is I take 180 and I subtract, okay, what we call that reference angle right there. And so my other possibility here is that this could be 131 degrees. And in this case right here, it does look like angle C should be that 131 degrees there. Okay? So that is the essence of the ambiguous case. When we get to this point in using the sine law, are we using both of those angles? Now, it could be, for example, that we're just using the one angle. Maybe this big angle doesn't even make sense. And you'll see what I mean in just a bit here. So maybe I only use the one angle. Maybe both of them end up being reasonable results here for the scenario. Or it could be that given the scenario here, neither one of those angles work here. So typically with these problems here, with the sine law problems where you're looking for an angle, you could have, okay, 0, 1, or 2 solutions. And then it's just a matter of trying to, trying to figure out what they are here. So take a look at this just to kind of give a further explanation of this. 2 students each constructed a triangle with the following measurements. Angle D is 20 degrees, side D is 5, side F is 10. And now look at what's happening here. So I'm going to let D be 20 degrees, I'm going to let a little d be 5, I'm going to let F be equal to 10. But notice what happens here. It could be drawn like this, okay, where this angle F here, opposite the 10, is acute. Okay, so right here, this could be acute or quadrant 1. Or, using the exact same values here, But this time what we do is we swing the 5 here, this line right here. Bear in mind that I don't know how long E is supposed to be. I wasn't told. So I'm going to take this side D here. I'm going to swing it, kind of pivot it on at that point E, bring it over, and now F is this little one. And now angle F here, this is going to be obtuse, okay, or quadrant 2. Both of these triangles have exactly the same characteristics described above. So then the question is, if all I do is give you these bits of information, which triangle am I referring to? And that's why we call this the ambiguous case. I don't know which triangle it is we're referring to. You have to deal with both. So in this case right here, when it says solve for F, well, we're going to set up our sine law. So that'll be 5 over the sine of 20 is going to equal 10 over the sine of angle F. We are going to, oh, I can't believe I just did that. We're going to cross multiply, and yet I clearly didn't do that. We're going to cross multiply is equal to 10 times the sine of 20. So the sine of F is going to equal, I'm going to divide both sides here, so it'll be 2 sine of 20 degrees. Now, I'm going to evaluate that. So the sine of F is going to equal, well, let's see, 2 times the sine of 20 is going to be 0.6840. Now, usually we go to 4 decimal places when we're looking at the ratio. I think it makes sense to stop at this point here because it's clearer here when you see the sine ratio as a decimal instead of connecting it to the problem here, because usually when people see this, they know, okay, there are 2 quadrants where these answers could be. So when I do the inverse sine of 0.6840, okay, now I'm going to use the whole decimal in my calculator when I do that. The inverse sine of that answer, calculator will immediately give me a first quadrant, okay, angle, 43 degrees. That's my acute angle, so that's corresponding to this one right here. And now what I want to do is I want to consider the other option, which is going to be the obtuse angle, and I get that by simply going, make sure you can see that, 180 minus that reference angle, that first one that we found, and we get 137. We'll round that to the nearest degree, 137. And that's going to correspond to what Ali wanted right there. So those are my 2 possibilities. Now again, which one is it? I don't know. It's ambiguous. It's not clear which one it should be. So let's go and just look at this real quick. So when 2 triangles can be drawn with the same given information, we call this the ambiguous case of the sine law. Now, this only occurs when the information that you're given is such that you're looking for the angle and you're using the sine law to get the angle. Okay, if you're using the sine law to get a side, doesn't happen, doesn't pop out here. It's only in this situation here. So this possibility may occur when you're given an acute angle, when the given acute angle is not between the 2 given sides. So in other words, we're dealing with a sine law, okay? So to give you a bit of a situation here. So if you have the above situation, you must consider the possibility of ambiguous case. And just like they're saying here, sine is positive in quadrants 1 and 2, and so that's why that would pop out. Okay, so there's a bit of the theory here. Now let's take a look at some questions. Okay, so let's take a look at a question here. What does it say? It says round angles to the nearest degree and size to the nearest tenth. Sounds good. So in triangle DEF, so now I'm just going to draw a standard triangle here, DEF. I'm not even going to try to make it correspond to whatever it says up here because I'm not going to be able to do that. E is 48 degrees. Sounds good. Little e is 9. So as soon as I have that pair there, I feel comfortable that this is a sine law problem. D is equal to 11. And so I want to find angle D to the nearest degree. Okay, so because the unknown is the angle here, I now suspect that there could be a possibility that I'm going to get an ambiguous case. Now, but we got to be careful with this. So here we go. I'm going to go 9 divided by the sine of 48 is going to equal 11 over the sine of the angle D. I'm going to cross multiply. 9 times the sine of D is 11 times the sine of 48. So the sine of D is going to be 11 sine of 48 degrees over 9. Okay, now whatever this is, okay, whatever it is, I know there's going to be a first quadrant and a second quadrant version of it. So what I'll do here is I'm going to enter inverse sine of 11 sine of 48 divided by 9. And notice I can do this all in one step on my calculator. I don't have to break this up into pieces. I'll just let the calculator do it. So this gives me, first of all, the possibility that the angle D might be 65 degrees. But I know that that's just the first quadrant version of that. So I'm going to subtract and get that the second quadrant angle there could be 115 degrees. Now, I don't know if those both work. Here's how you check. So I have two scenarios here. So I've got two triangles, triangle 1, triangle 2, and I've got angles D, E, and F. So I know that angle E is 48 degrees regardless, because that was what was given to me in the problem. I can't play with that. But now I've got two options for D, 65 degrees and 115 degrees. Now, I want to figure out what F is, and it's actually angle F that tells me if this worked or not. So what would angle F be in this first case here? Well, I would go 180 minus 65 minus 48, and I get 67 degrees. Okay, well that works, that's fine. Now in the second triangle, 180 minus 115 minus 48, ooh, that's small, but that still works. Sometimes what you get here is that this ends up being a negative angle, in which case that is the only answer you get. And so the ambiguous case only spits out, when you're looking for the ambiguous case, you only get the one answer. Okay? And that's how you check it. You look for that last angle and see if that last angle makes sense, and that tells you what kind of a scenario you're looking at. Okay, so this next question here says solve the triangle, which means find all the missing sides and angles. If triangle XYZ, so let's look at that again here. Okay, XYZ, whoops, stop the screen, where Z is 33 degrees, angle Y is 112, and Z is 28. Okay, now in this case right here, this will not be an example of the ambiguous case of the sine law, because there is no ambiguity here. If I want to figure out what angle X is, I'm simply going to go 180 minus 112 minus 33. I know that X is 35. Okay, angle X is 35 degrees. Now, I've got to find little x and little y. Whoops, you couldn't see that, 35. And now what I can do here is just set up my ratio. I've got 28 over the sine of 33 is going to equal, let's find x first, x over the sine of 35. I will cross multiply. I will divide, because I'm looking for x here, so it's going to be 28 sine of 35 degrees over the sine of 33 degrees is going to equal x. And I go to my calculator, so 28 sine of 35, got to make sure I close the parentheses there, divided by the sine of 33, and I get 29, and we'll round that to the nearest tenth here, 29.5. And then I do the exact same thing to find y. So I've got 28 over the sine of 33, that's the z and the angle z, and then y over the sine of 112, cross multiply, and divide, so 28 sine of 112 degrees over the sine of 33 degrees is going to equal y, and then again that's just calculator work at this point. So 28 sine of 112 divided by the sine of 33, and to the nearest tenth, 47.7. Okay, so therefore, angle x is 35 degrees, little x is 29.5, and little y is going to equal 47.7. And so now we've solved the triangle. Again, notice that there was no ambiguous case here because we weren't looking for the angle in that question. Okay, for this question, triangle ABC, so let's do it again. ABC. Angle A is 43 degrees, got it. Little c is 28.5, Got it? Little a is 36.1. Got it. Now we're going to find angle C. Okay. I've got the angle A and little a. Okay, so I can set up this ratio right here. And then I've got little c, and I'm looking for angle C. Because I'm going to use the sine law to solve for an angle, this could be an example of the ambiguous case. So it's 36.1 times the sine of c. I'm going to cross multiply, and I know some people don't like it when we call it cross multiplication, so because there's no operation, cross multiplication. However, what I want you to do is I want you to multiply across the equal sign. I tell you what, just for fun, let's call it cross multiplication. And so now, to get what c is, I'm going to take the inverse sine of 28.5 times the sine of 43 divided by 36.1. Okay, and so I'm going to get here that angle C, and we're going to round this to the nearest degree here, so it's going to be 33 degrees. But remember that that is my first quadrant angle, so to get my second quadrant angle, I'm just going to subtract that, and I will get 147 degrees. Okay, now, will do those work? I don't know. I've got two possible triangles here, angle A, B, C. Angle A is 43 degrees in both cases there, because that was given to me right from the beginning. C, well, C could be 33 degrees, or it could be 147 degrees. Now, in this first case here, I can figure that out. That's going to be 180. I can figure out what B is, I should say. 180 minus 43 minus 33. Okay, so angle B is 104 degrees. That's fine. In this one here, it's going to be 180 minus 43 minus 147. Oh, that's negative 10 degrees. Well, that doesn't make any sense. So this right here, well, that doesn't work, which means this part right here doesn't work. The only answer that makes sense to this one is 33. So there is no ambiguity in this particular problem. The possible other solution simply doesn't work here. The answer is just 33. Okay, another one. Sketch and solve the triangle KLM. All right, here we go. Same as before. Let's just draw it however. Angle L is 46 degrees, little l is 3, and little k is 4. Now, we want to solve the triangle. So we're going to look for everything we don't know. Okay, so I have got the ratio 3 over the sine of 46 degrees, and that is going to equal, in this case right here, the best I can do is 4 over the sine of k. And now we'll cross multiply and divide. So 3 sine of k is going to equal 4 sine of 46 degrees. So the sine of k is going to be 4 sine of 46 degrees all over 3. But then I remember, okay, I know that when we're in a situation like this, there are two possibilities. Now let's take a look here. Get that answer. So this is going to be the inverse sine of 4 sine of 46 divided by 3. Okay, I'm going to round that to the nearest degree because that's what we're going to do with angles here. So k is going to equal possibly 74 degrees, or 180 minus that to put it into the second quadrant, so 106 degrees. Okay. Now, those are my possibilities here. But let's take a quick look at that. Do those both work? Now, if they both work, then I've got a fair bit of work ahead of me because I got to figure out what the other sides are, or other side for both triangles. So here's what I've got: triangle 1, triangle 2. We've got angle KLM, but then we've got sides, little k, little l, little m. So in triangle, let's see, in triangle 1, I could have, L is 46 degrees. That's going to be true for both those triangles. We know that little l is going to be 3 in both the triangles, and little k is going to be 4 in both the triangles. I have no say in that. That was given to me in the problem. I know that angle K could now, however, be 74 degrees or 106 degrees. Okay, so if that's true, in triangle 1, what would angle M be? Well, it's going to be 180 minus 74 minus 1, oh, oops, sorry. Wow, I looked over that real quick. Minus 46. So M will be 60 degrees. In triangle 2, it's going to be 180 minus 106 minus 46. And I get 28 degrees, which means both of those work. So I have two possible triangles here. So what I have to do now is I actually have to find both possible values of M. Sorry, that doesn't look right. There we go. Okay, well, let's start with the material that I was given initially. We've got 3 over, so this will be for triangle 1. 3 over the sine of 46 degrees is going to equal little m over the sine of 60. So 3 sine of 60 is going to equal m sine of 46, and so I'll divide 3 sine of 60 over the sine of 46 is equal to m. Oh, that's almost off the screen there. And now let's figure that out. So 3 sine of 60 divided by the sine of 46. Now, and I realize that I'm using rounded values at this point here, and so my answers are going to be slightly off, and I apologize for that. It would have been better if I'd used kind of exactly the value that they gave me here, but I lost track of it. Anyway, this will give you a rough idea of how to do it anyway. So 3.6. Okay. Now, I can put that right there. For triangle 2, same sort of setup here, 3 over the sine of 46, but this case here it's going to be little m over the sine of 28. Okay, I will cross multiply. 3 times the sine of 28 is going to equal m times the sine of 46. Throw 3 sine of 28 over the sine of 46 degrees is going to equal m, and that will equal, and we'll just take a moment to do that, 3 sine of 28 divided by the sine of 46. Ooh. 1.9, okay, so rounded to the nearest tenth, that'll be 2.0. Oh, so quite small, so 2.0. Okay, and there you go. Now we've solved the triangle or triangles that are possible results from that given scenario. Okay, so in this question, triangle ABC, I'll draw it out here, ABC. A is 30 degrees, little a is 5, little b is 10, and we want to find angle B. Okay, well, that's kind of nice. So we've got 5 over the sine of 30 degrees. So that's my little a over sine of A. And this will be equal to 10 over the sine of B. Again, because I'm looking for an angle and I'm using the sine law, this is definitely a potential ambiguous scenario. So the sine of B will equal 10 sine of 30 degrees over 2. Now I can simplify that down, but at this point it doesn't really matter because I'm going to use my calculator. And I'm going to let this be the inverse sine of, okay, well 10 divided by 2 is 5. So 5 sine of 30 degrees, close that off. Oh, well I got an error. Okay, let's think that through again. Let's just see what happened here. So let's take a look at the scenario. A is 30 degrees. Little a is 5, b is 10. Okay, find angle B. Let's make sure we set this up right. 5 over the sine of 30, 10 over the sine of b. Don't know what that is. I cross multiplied. Yeah. Divided. Okay. 5 times the sine of 30 degrees. That seems right here, but I'm not getting a solution when I do that. You know what's going on here? Let me draw this again here just to give you an idea. Here's my side here, and it's a length of 10, and then I've got this angle here of 30 degrees. The opposite side here is supposed to be 5, but what ends up happening here is if I draw a semicircle here where the radius is 5, it turns out nowhere do I ever come in contact with this particular side because of that angle of 30 degrees. So when you see this popping out, you should go through and double check everything, but actually that simply means there's no solution. This doesn't work. Okay, the scenario being described here simply won't create a triangle. Okay, now for our last question here, we got triangle GHI. What do we got here? G is 50 degrees, little g is 17, little I is 25, and we want to find angle I here. Okay, so we've got enough to set up the sine law, so it's going to be 17 over the sine of 50 degrees will equal 25 over the sine of I. And we're going to cross multiply, so 17 sine of I will equal 25 sine of 50. So the sine of I will be 25 sine of 50 degrees over 17. So I will equal, let's go through and take a look at this. Second sine, it'll be 25 sine of 50, 50, close bracket, divided by 17. And I'm getting an error again. Now, this time I want to double check because it kind of seems sort of unlikely that they would do that twice in a row here. 25 sine of 50 divided by 17. If this is bigger than 1, okay, it's bigger than 1 here. So I'm going to double check that I've set that up right. So 17 sine of 50, 25 over the sine of I. Cross multiply, divide. Yeah, that's it. So this doesn't work. So again, what we're getting here is no solution. Okay. So anyway, there's some examples of the sine law, the ambiguous case of the sine law, why it shows up in the scenarios where it shows up, and I hope that makes sense. And yeah, that you're prepared even for situations like this where there's no solution.